Okay, so this is the April 11th Robot Builders Night virtual for Dallas Personal Robotics Group. We meet every Tuesday at 7:30, so and everybody is welcome to join us. So the recording is now going, guys. Okay.
Yeah, so I'm still just working on my little robot. I'm basically inching forward, trying to get a little more accurate, a little faster. Just small
Mm-hmm.
improvement. But but one thing I've noticed is, well, I reused some old servos, the cheap SG90s,
Yeah.
and uh, and I thought I could change them out like 2 weeks before the competition, but they're dying left and right.
Yeah. Yeah.
I have to change them out early.
Yeah. Are they the SG or the MG?
SG, yeah.
You might consider if you go into the MG, might give you a little more life. Uh,
Hmm.
uh,
I didn't appreciate or understand the difference, except they want to get a little more torque out of the metal, but the plastic seems to work fine for me. But
well, it's not the torque; it's the just life. Life.
life,
Yeah, you don't
because
get stripped gears as easy.
yeah, yeah. Well, I think I'm not sure what's going on. It gets sort of erratic, like it sort of sticks, then it moves again.
Hmm.
It sounds almost like it's electronic, or
Uh, if you've got some spares, I would recommend that you might take one that you think is sticking and open up the gearbox and look in there and see if you haven't lost some teeth on some of the gears.
hmm,
And that might be what you're seeing. You got some gears stripped out, so the thing whirls around, and you hit one of those dead spots, and it looks like you're glitching, but you
yeah,
keep going through it, and because your servo's not, if it's not moving, it's still giving you the same um, feedback, so it'll keep twirling until it hits the right spot. So you might find, like I say, hey, maybe I'm wrong. Just open it up, and if they're not hard to open up and put, close
yeah.
back up.
And I found a few that were drawing a half an amp. Like what? What the hell happened?
Yeah, that sounds bad. Now that sounds electrical. Yeah.
Yeah, yeah. So, so, and also, I think someone trying to warn me or said, "Hey, you shouldn't." I wouldn't use mechanism wheels. And I'm noticing that for some reason they every once in a while they spin and they lose traction, and it sort of freaks out, and I can't quite figure it out. I think I have a feedback loop that tries to correct it when it's not moving in the right direction.
Mhm. Mhm.
and and I used to have it on all four wheels, and I just took it off and just did it on the front two wheels. I think I'm gonna restore it back to all four wheels so that when it gets in some weird spot, and it has more ways to get out.
Yeah.
Yeah, my four's pretty smooth here, so I'm not sure, but I can now appreciate the three wheel design is real nice if you have unlevel
Mhm.
fours.
Mhm.
Or a
Yeah.
four wheel design, little nuts. So
Yeah. That's Carl ran into that problem at the makerspace because the floor is not very level in the room that we do most of our competitions, and his robot would hit one of those spots where three of the wheels would touch and one would just be in the air. And
Yeah, that one corner, there's
yeah,
like a foundation issue. It slopes down quite a bit.
yeah, yeah. So that can happen for sure, Michael.
yeah, and my robot's not very heavy, even though it has a big battery. Maybe need to put some lead on it, make it a little heavier.
No ballast. Huh?
Ballast, yeah.
Hey, David.
Yeah, so basically
Paul.
it's just a job, but I'm just trying to shave off seconds here and there by making it more accurate and just doing things quicker. Like
Yep.
trying to reduce this.
Yep.
That's about it. I'm just working.
Yeah.
Getting better. It was one. It was like diverging from being good. Now it's back to being better.
Yeah. So, long time not see, Dave. You got anything you want to say?
Well, hi everybody.
Hi.
Is anybody? Uh-oh. There we go. Anybody building any robots?
We're
My
trying.
absence?
Trying. Mike just finished talking about some of the issues he's running. He's got a fairly it's a completely new design for him, I believe. He's got mechanical wheels, and his drive motors are actually converted servos. If I understood him right, that's right, Mike.
Yeah.
Yeah. So. So that's a little unusual. And Ray has been working on a really unusual robot. We're going to see how that one comes out.
So I have 4 servos. 4 are converted into wheels, and the other 4 are just servos.
Yeah. I'm trying to get my old code base back into my robot so that it will work, which is, that's harder than it looks, David. But anyway, because I had worked on other robots, and now I'm coming back to this one, and it's been a bear. But I did make some progress this week. So anyway,
I work on the code, and it gets really big in the main file.
Yeah.
And then every once in a while I'll fluff off a library.
Yeah.
Arduino.
Yeah.
And it's about time for me to do that again because it's getting a little unwieldy.
Mm-hmm. Yeah.
I have a question for Paul. When I was driving home today, I drove past this great big gravel truck, huge thing, and it had, tandem wheels in the back. And I started wondering in terms of the standard equations for Ackerman steering. You normally would draw a line through the rear axle out to a point that matches the angle that the front wheels are turning. But how would that work on a tandem axle? I guess both wheels slide and it's the point in between. And I thought, who would know this? And I thought, I bet Paul knows this.
So you're talking about a tractor with a trailer, right? So
No, just a great big, gravel truck, just a big truck with a pair in the back and 2 wheels in the front.
Oh, okay, yeah. You take the center of rotation. What our navigation guy did at Lockheed Martin was take the center of turn to be the midpoint between the 2 rear axles.
The midpoint. So
Yeah.
that pretty much guarantees, since they both have differentials, that both sets of tires are going to be sliding, right? In a turn.
Right. I mean, they do both slide as it turns. Now, you can imagine scenarios where they would turn, one might slide and the other not. For example, if one is on some gravel and the other's still on tar seal. But for the equations, we use the midpoint between the 2 rear axles.
Interesting.
And that was true
was
tractors as well, like 18-wheeler tractors for 18-wheelers. So even though it wasn't necessarily a long truck, for the shorter trucks that were a tractor, we'd use the midpoint between the 2 rear wheels as the center of the turn.
Interesting. Okay, that's only moderately robot related, but I was curious.
Yeah.
And I thought Paul surely knows the answer to this.
Oh, I was thinking, Dave, you had a new robot with tandem wheels in the back.
pretty
Well,
impressive.
I haven't done any roboting in I
Wow.
won't even say it's going on years.
Yeah.
Um, and just recently, I decided to pull out the balancing robot you can see over my shoulder
Yeah,
here,
yeah, I see him.
and see if I could get him to come alive. And I've tracked. I'm working through it. I've tracked down to one of the encoders is not working, and these encoders, these were handmade encoders. What
Oh,
I did was I printed paper, stiff paper, uh, with a whole bunch of divisions. I think I have 64 divisions. I read, and there's a pair of those. Oh, I can't remember the name. Those little tiny Hamamatsu um, IR
Photo
detectors.
interrupters.
Yes, it's not interrupter. It reads the reflection, so it's got a
reflection.
little LED
Oh,
and a little detector in the same thing, and it's like that big. And I've got two of those at 90 degrees to each other to get the quadrature. And one of the reasons I like that is because the disc is really light, and so it doesn't vibrate when you start spinning really fast. You get a heavy disc, it has to be balanced, and it gets harder. And then I super glued those to the end of the motor shaft. So my suspicion is that that super glue has come off, and I got to take the whole robot apart to get into that motor and pull off its encoder and look at it. It was mounted in the back of a black plastic film canister. You guys remember those?
Mm-hmm.
Which exactly fits over the motor. It's just a perfect fit. Put a little cable tie around it. So as I was looking through all this and thinking about pulling the whole thing apart, I thought maybe it's time to upgrade those encoders to something else.
Mm-hmm.
A little bit I've seen, rumbling about. Everybody seems to be talking about using, Hall effect and magnets, which seems to me, as I was saying, it seems like what you want is a light encoder to attach to the motor shaft, not a heavy one. And it seems like magnets and things like that are heavy. So, anybody here have any comment on that?
Well, I think you're talking about like the encoders that they use on a lot of the Pololu style motors and stuff. They're really, first of all, you can get them from Pololu, so they're not hard to get, and they're not that heavy, David. They're really pretty light. Yeah, I mean, and they have the advantage of that because they usually go straight to a comparator, that you have nice square waves as opposed to sort of half sinusoidal waves that you have with a reflective. I mean, you can obviously use a comparator on a reflective encoder, but a lot of them, especially homemade ones, don't do that. So something to think about.
Well, I just thought maybe as long as I pull the whole thing apart, and I haven't. This is a vulnerability in the design. I've had to take them apart before, and there's just a little tiny bit of the motor shaft sticking out. And as I said, so I super glue the little paper disc onto the back of that.
Yeah. Yeah.
My suspicion when I get this one apart is I'm going to find that paper has come off.
Mm-hmm. I know that I used to use paper discs when I, glued to a wheel or third piece of plastic or something. When I was more conscious of money than I am now, and it's one of those things that
It's a time money trade-off.
Yeah. I think you're gonna like the little magnetic disc.
Yeah, they're not bad.
They're not bad.
Blues.
So I
Got
should
one. I
get a
think they have
polo and poke around.
a 20. I think they refer to it as a 20 transition per revolution. In fact, I think I have one. Yeah, there's one there. That's the 20 count, and it includes two magnets and two things.
There's
They're
so
made
much
for a
light
certain size
reflecting
motor.
off the bag, Ray, that I can't really see it.
Oh, is that better? Whoop.
If you look, he's got two magnets at the top and
Yeah.
two encoders at the bottom. and
Right.
they're usually made for a specific size motor.
Right.
And I haven't tried it, but since I believe they're ceramic motor magnets, it might be tough to drill the hole out of the middle. Have you tried that, Ray?
Yeah, I've tried it. It seems to work.
Okay.
How do you fasten them on?
Say that again?
I'm sorry, I'm eating. How do you fasten those onto the motor shaft?
Oh, there's two little holes for the armature connections. So they're made for a specific size motor.
That has
the
like
hole
two
is pretty
posts in the back.
Yeah.
And then you solder it directly to the motor armature connections.
Yeah,
Yes,
to the armature
yeah.
connections, and then there's like 1, 2, 3. There's 6 holes on the bottom for, power, ground, 2 outputs.
So
I
it's
don't know what the other
it's
2
soldering
holes
to
would be.
those motor posts that holds it in place.
Yeah. Yep. It's kind of like. Yeah, there's an example of a Palulu motor with the encoder in the front, and it's soldered. Let's see, right there and right there. Those are the 2, connections to the armature. So, and they seem to work pretty good. They're pretty rugged.
Mm-hmm.
So does the motor shaft stick through that little board?
Yes, yes.
Yeah,
Well, yeah,
enough so you can get the little.
I don't
disc
have
on
a
it.
motor shaft that long.
That could be an issue.
That's why I say that's why I have a little paper
Yeah.
disc super glued to it.
The magnets are pretty thin. I'm guessing maybe 2 millimeters. So if you have at least 2 millimeters sticking out the back, well, okay, you need a little maybe 3 millimeters for the printed circuit board and the 2 magnets to fit on the shaft. But on that first robot that I was using for 6-can and can soccer, did something similar. 3D printed it though. Had a little disc with a bunch of slits in it. It's been pretty reliable. Nothing, as far as I know.
You're reading it with a interrupter.
Yeah. Yep.
It's the universal symbol for an interrupter.
Oh, yeah.
I don't know.
I thought it was. You sure it isn't this?
Anyway, those pink plastic things cover the back of the motor with, and it has the interrupter.
Those look just like the motors I have on the balancing robot. What are those?
Oh boy, they were a Tanner special.
That's what mine were.
Oh, probably the same thing then.
And I think we're talking about the same vintage.
Yep. Yep.
And,
They're
so
not that big.
On mine, the only difference is that those pink things are black plastic film canisters.
Oh, film canisters. Yeah. Yep.
I think I threw the last of those away just about a month ago.
I was pining nostalgic for them, and my wife found them online and bought them for me.
Yeah. Yeah.
Yeah, they're not very big motors. I mean, they're pretty small. There's one with the code wheel stuck on the back, or the wheel stuck on the back.
Okay. And you
And,
3D printed those?
Yeah, there's another one with. Yep, it's tied to something else in there. Oh. Anyway, there's the cover with the opto interrupter in it, mounted on the back of the motor.
Looks very pro, Ray.
Yep.
Hey Ray, David asked if you 3D printed the disc.
Yeah,
Okay.
yeah, I could get about 30 slots on it. It's not quadrature. It's just, you know,
Speedometer.
yeah, like a, I don't know what you call it. I guess it's still an encoder, but
Hmm.
You know, one of the things I discovered was that I have a robot that actually can do odometry real well that doesn't have quadrature. I just take the sign of whatever was the last motor command I sent,
Hmm.
and that seems to work.
Yeah.
The only time, you know, when you really need to know that is when you're going through zero, and for robotics, we don't do that very much. You know, you mostly, I guess that's not true if you're spinning in place or something like
Hmm.
that. But, you know, I was actually surprised that it worked as well as it did.
yeah, it was pretty reliable. Occasionally, you know, loose nut on the wheel with that thing, but because there's so many nuts on it, it's nuts and bolts. I mean,
And then you have the PID controller responding to those loose nuts and bolts. I've seen that happen where I thought, what is wrong with my PID controller?
mm-hmm.
When I tried to get this balancing robot to balance, when I first charged the battery the other day, and I didn't know one wheel wasn't working, but what was amazing was that it could balance with just one working wheel.
Wow,
It
that
kept
is good.
turning. It wasn't going forward and backward. It kept turning, but it didn't fall over. So impressive.
Yeah, that was the problem with these little motors. They didn't have a very long shaft, so you know any hub that you were going to put on it, there was very little to grasp there. You know, so like the thing would just kind of work its way off and potentially just you know lose a wheel.
Hmm.
And it was you had to take pretty much the whole hub apart to get to the set screws to tighten them up. So it's like pull it off, tighten the set screws, put everything back together. So,
Is Harold frozen? Nope,
nope.
he moved. Okay. Yeah.
He moved.
Yeah, because I was thinking Harold's been working on a balancing robot here for a while, and I think he might have some questions for you, David. You got any questions for him, Harold?
Oh, I got tons of questions. I'm actually on a mission to get my wife a birthday cake. So when
Very
I'm
good.
putting the importance of things, balancing a robot with David, which is awesome,
Yeah.
versus birthday cake for my wife. That priority thing comes
Yeah.
into
Well, now,
play.
Harold, did you get enough birthday cake to share with the whole group?
Well, yeah, but I can't get it. I can't jam it through the speaker and get it to you. So can't really get that. If I could do, we don't have Wonka vision. If we had Wonka vision, I can make that happen. Of course, I'd have to get a birthday cake the size of the house because it makes smaller on TV. You know how that
Yeah.
works.
Well, nobody asked anything about my wife's brownies. I'm still just trying to get them out of my teeth. You're welcome to come over and get some, but I ain't bringing them.
Were they medicinal?
Uh, they were for me. They were legal too, so I guess that answers your question.
Okay. Paul, you said you had something you wanted to share? You said it wasn't quite robot-y, but it was kind of robot-y.
Yeah. You just find the right. Uh, well, I guess I don't think I have any papers or web pages ready to share, but I want to show this. It's has anybody heard of Amazon's new network called Sidewalk?
Mm-hmm.
So they just opened it up. It's apparently, and that's what really this I thought was interesting for this group. Sidewalk is a network that uses LoRa for long distance transmissions up to 5 miles. BLE for Bluetooth for nearby transmissions. And if you have a Ring doorbell or a Ring light, outdoor light camera wired, or an Echo Dot 3, or maybe a few other Echo products, they are actually bridges to Sidewalk. And Amazon has instated a opt-out policy for the Sidewalk network and the gate. I'm sorry, the bridges. They're called gateways is the network term for them. But what they are is bridges from an Internet of Things thing, an IoT thing, that could be around your house, could be a mile away or more, and you share a little bit of your home network bandwidth that your Amazon device is using, for its legitimate purpose, with any IoT devices that want to communicate to the Sidewalk network. And so it's kind of an interesting model. It was tried once before with Wi-Fi, but they cap data rates at 12 kilobits per second, I think. So it's pretty low down in noise. It's a 40th of the bandwidth required for HD stream for an HD stream, and the kind of so you guys know about tiles, right? You can get them on Amazon, location tracker thing. So those things have been used using this Amazon Sidewalk. Well, before it was called Sidewalk, this network existed, and they used that for communicating their location. So they got GPS inside them, and then they talk over Sidewalk to back to the tile headquarters, and that tells you where your tile is. And so earlier this year, Amazon opened up Sidewalk to the public, and meaning that they're making it freely available for anyone who wants to build or buy devices that use Sidewalk as a link, a network to do that. And so the kind of applications that it seems to be well suited for are maybe pet trackers, or someone's building a dementia patient tracker, so if they wander off, you can find them. It seems to me that when you compare it to alternative networks, it's got much longer range than Wi-Fi. Wi-Fi stops at the front door pretty much, and their goal was to have a network that went beyond the front door. It's much being LoRa-based. It's much lower power than cellular, because cellular is pretty high power. Like you wouldn't have a cellular radio on your dog collar that lasted all that long. I don't think.
Somewhat around a watt, like 1.2 watts, I think. I think it's common.
Okay. Yeah, that's quite a lot for a little, like a collar-mounted or wrist-mounted device, whereas LoRa is very, very low power. So I think from technical standpoint, it's kind of interesting for robotics because that's enough bandwidth. Oh, and the other thing is for coverage, uh, Amazon estimates that 90% of the U.S. population is covered by by the sidewalk network. And let me just see if I can find um, uh, the sidewalk map. Um, well, it's not gonna.
You get like an army of little robots that go out and seek.
Yeah, I think that. Oh, here it is. Let me just share that out. Um, that one. Are you all seeing this? My page from the
Yes.
Verge.
Yes.
So let's just see if we can zoom in a bit. Nope, not so much. So anyway, you can kind of see there is a website somewhere that you can actually interactively zoom in here, and basically all of Little Elm is covered, and it's basically around suburban areas where people have these Amazon devices installed. So there's a number of things I think that are interesting about that, and let's see. So there's also I read the security white paper last night, and it's pretty interesting the way they've got layers and layers of encapsulation. So the IoT device manufacturer. Oh, another use case is for things that are just kind of sort of out of range of your Wi-Fi network. They don't get reliable communication. So Sidewalk can be a backup for them. Like, for example, a light in your backyard might be just a bit far away from your Wi-Fi, your home Wi-Fi hotspot to turn it on and off. But it would be well within range of Sidewalk. But the thing about Sidewalk is it's a IoT device to cloud application server model. So it's not you as a homeowner and as the owner of the Amazon device that is the gateway for Sidewalk. You don't have access directly to go directly through the network like you would on your intranet inside your home. You've got to go up to the cloud to the application server, and then it sends commands or gets data from the device. And
is that like UTT?
Like UDP?
MQTT.
Oh, MQTT. Yeah, it's right. You could think of the application server as being like an MQTT broker, but it's necessarily in the cloud because of the arrangement of the protocol stacks. So they draw it as concentric pipes. You have a concentric pipe carrying application data from the IoT device up to the application server. So it could be data from about whether it's night or day outside, and carrying commands back down, for example, to turn a light on. And then that's all encrypted, so it's not visible to Amazon. So the IoT device encrypts it using keys that it's pre-provisioned with when the device was manufactured, and the device has a unique ID that is the basis for the keys. And so you go through a registration process for registering, like you create your account with whoever delivers your application server, like could be Tile or could be mydogstracker.com. And you register whatever IoT device it is, and then messages are encrypted and not visible to Amazon between the IoT device and the application server. And then the there's further another pipe, concentric pipe outside of that is the routing pipe. So your IoT device sends out a message. It's picked up by some gateway, maybe yours, maybe a neighbor's, maybe you're across town from you if you're not near home, and that encrypts the IoT device packet along with routing information of where it's supposed to go to. So then Amazon doesn't even see where it's supposed to go to, except at the network layer. So then there's a layer above that's another encryptor. They call it the flex layer. Anyway, it's a really interesting idea from a number of standpoints. One, it seems to provide a lot of privacy. But Amazon can't see what data is being transferred, can't even tell, but it can tell what gateway is being used, I believe. But it doesn't know what kind of device is on the other side, is using that gateway. So there's a lot of privacy between the company that's providing the application and Amazon that's providing the network. Another interesting aspect is, well, they're using a little bit of my internet bandwidth, and I never said that was okay. I think I'm okay with it, but what if there was a hole in the bridge and it could be exploited to leak out into my intranet? So things when they come out in the first generation are always broken. So I think we would likely see some bugs, maybe some hacks, exploits around this, perhaps. Another is the use cases. I get the sense that the idea for how it's exactly to be used is not well understood. They're really putting it out there for inventors to try out and use and come up with applications. And the bandwidth is, I think, enough that it could be interesting for some types of robot data. So not detailed logs, but perhaps higher level commands to do this or do that. Obviously not video, but it could be interesting for some robotics applications.
Paul, you mentioned the bandwidth of, I think you said 1200 bits. So we'll just call that 9600 baud, basically.
No, 12 megabits.
Megabits. Well, that's lots of bandwidth.
Yeah, it is quite. It's pretty respectable.
Yeah.
And then they put a monthly cap on it as well. So they're really trying hard to make sure that they don't impinge on users' bandwidth on their home network, because otherwise they'll get all kinds of blowback.
Mm-hmm.
But it does mean that if we're using it for, say, robot telemetry, we're using somebody else's device,
Yes.
camera or whatever,
Yes.
basically without their knowledge or even permission, really.
Exactly. So that's one of the interesting aspects of it. You can make your own decision about what you think about that, but that is what it's based on.
Okay, up in the mountains where we have our cabin, the Wi-Fi there, we don't have any passwords or anything.
Right.
So that other cabins nearby, and they don't either. Other cabins nearby can see us, we can see them. It's kind of like leaving the doors unlocked when you go fishing.
Right.
But I'm not sure that I'd do that in, Detroit.
Yeah, I certainly wouldn't do that on my home network here in Little Elm. But I think, we're always wrestling at Roboramas, wrestling with Wi-Fi and not having enough, interference between devices, and just Wi-Fi is a continual headache. And this might be an interesting approach to interesting solution to that issue.
Well, I'd be interested to know what people are using for their telemetry now. And I'll volunteer to start. I use XB. So I do have just 9,600 baud.
You cut out, Dave. I didn't hear what you said.
I said I use an XB.
Oh, okay. Well, I use an ESP32 and the ESP32 Now protocol, which is Wi-Fi like, but not, it's separate from Wi-Fi.
You have to have an ESP32 on both ends?
Yeah. You do.
Mhm.
And you can do it.
I'm just using Wi-Fi.
What's that?
I'm just using Wi-Fi.
How are you?
Yeah, me too.
Yeah, that was going to be one of my questions. It's one of my problems with my bouncing robot is because when I attach something to it so I can see the data to figure out what it's doing, the mere attaching of the thing upsets the whole balance of the thing, and so I can't get good data. So
You've made that discovery. You can't hook up a wire.
I made that discovery a long time ago.
It's like balancing a pencil on a point. That wire is real heavy when you're exactly balanced.
It's very, very heavy.
Yeah, and it'll throw it off. Yeah, you can't hook up a wire.
And I'm like, okay, so how do I get that data back? I've been manually trying to adjust some things. In fact, I've gotten so frustrated with it, I've set it aside for a little while. And
Harold, I never tried to do that in real time. I would log all the data on the robot itself while it's doing a run,
and then you'll build off of it,
and then dump it when it's done.
It's running on a Nano right now. What I'm thinking I'm going to do is I got a Pico W, depending on how you want to read those words, and I think I'm going to do something very similar with on one of the processors throw up a web page and the other or a web type service, and the other process have it do all the things, and then use that web service kind of as a logger or a way to get pictures or do something like that, so that I've got a connection to it so I can see some numbers at least, and then we'll worry about how we log them and how we do graphing and all that other kind of stuff. And but I pushed all that away. I'm doing something else now.
Well, do you have questions, Harold?
I do have questions, but I don't have good ones for you right now, David. And I will ping you at some point.
Bad questions will be entertained.
Well, yeah. Most of them. Okay, why don't it work? There you go. That's the question.
I can tell you.
What? Because I did it?
Well, first of all, because it's a deceptively hard problem, and what it really all comes down to is coming up with the appropriate gain factors, and since they influence each other, you can't change one.
What I was messing with, I had 4 potentiometers on it. One of them where I could adjust the set point because I know this thing isn't exactly 90-degree balanced. I know it's not. And then the other 3 were the PID, and I turned them to 0, and each one a little bit. It was doing better, doing worse, and then now it just all went to hell. So it just.
I'll tell you the other thing is with a balancing robot, when you're trying to get that set up right, when it doesn't balance, what it does is it charges off in one direction or the other and slams its head into the wall.
Yes, it does.
What is nearby? It's not a subtle crash.
No, it's not. It's not like, oh, I fell over. No, I'm going to F something up when I fall over as much as I can.
Well, also because, as it's falling, what it's trying to do is drive in the direction it's falling. And so when it gets past the point where it can't correct, the analogy I've always liked is when I was a little kid running down a steep hill. And, you get running so fast that you can't stop. Because in order to stop, you've got to actually speed up a little and get your feet in underneath your center of gravity. Yeah. And when you're running full speed, you can't do that. So, and typically the solution, and I've watched people do this, you start slamming your feet real hard into the ground to try to burn off some of that velocity, and that allows the feet to get in under the body and you can come to a stop. The other option is you just pitch forward, and especially the little kids who haven't worked all that out yet.
Just tuck and roll, baby. Tuck and roll.
Well, I will say, and I learned this from my bouncing robot, but I learned it first from my kids, which was that we always say you have to learn to crawl before you can learn to walk. But I found out that's not true. What you need to do before you can learn to walk is you need to learn to fall. because you're going to fall a lot. And if you bang your head every time, you'll never learn how to walk. So I remember my oldest, Stephen, when he first learned it, he pulled himself up, hanging onto the couch. And he was kind of wobbling back and forth, hanging onto the couch. And he let go, and he started to fall backwards, which he'd done before. And, you hit your head on the floor, and it hurts. And this huge look of determination came across his face. And he spun around, and he got his arms out in front of him, and he caught himself. And I could just see this little tiny infant going, "Not this time." But it's the same thing, and you may have noticed that this guy is covered with rubber bumpers.
Yeah.
All those rubber bumpers. This one even can move back and forth depending on which side you fell on. That same thing on the front. Those rubber bumpers top to bottom, because, as I say, it falls all the time. We humans fall all the time. Look at football, Those guys fall down every play.
Yeah, probably a little kid is very similar to an inverted pendulum. They have the big head. And...
I don't know. I'm a little inverted in my pendulum too, so I don't know about all that. So. But anyway, David, at some point when I get back on, I will ask you. I'm trying to, literally the goal of this thing is to make the simplest number of parts, pieces, and little thing possible that will work, because I want to expand on that to make my BB pie, which is way more complicated. So we started with this complicated thing, and I've been paring things down to the very simplest of things so we can figure it out, because it's a complicated thing, right? And we're down to the very simplest of stuff, and it's close, but like you just said moments ago, close ain't good enough, because when it's close, it'll look like it'll work, then it all runs to hell. So you got to get it right on in order to even, you got to be really close to be close.
And one of the things I found was that, when the robot is at really steep angles, when it has to fight really hard to stay balanced, then it requires a big motor that can torque and really move quickly.
That is one thing I was
but
surprised
that once
about.
you get it balancing, it doesn't get in that state very much.
Yeah.
Once you get it balancing, it just takes little tiny
things,
little tiny right? adjustments to keep it there.
That is one thing that I've done with this. I've got I got a motor controller, and I don't want to go into all of the things detail wise, but I got a motor controller and I got an RC battery, and the little motors on there. The initial design had 9-volt batteries on there, which that was never going to work after I've come to find out. But I've got an RC motor, I got an RC battery in there. I got a motor controller that can take all the current those motors can do. And the way those motors are, and then they're small and they're geared. They're like 300 to 1, something or other. They're more than enough to do all the stuff I need to do on this little bitty robot. I mean, literally, if I had it where it could touch the wheels, I think I could generate enough stuff to get it from a lying down to an upright if I had wheels big enough to do that. That's how much juice these motors seem to have.
As I said, my observation was that once you get the algorithm tuned, you really don't need that big of motors to stay down. You do in some circumstances. Like I was watching a few years ago at a robot meeting, and it ran into a chair leg, kind of knocked it cattywampus, and in a case like that, it really did need all that torque to not fall over. But in the nominal case of just driving around the room, once the algorithm is working properly, it really doesn't take much power to stay balanced. I've heard ballerinas tell me the same thing. When they go up on point, that you're fighting it and all your muscles and everything, it's taking an enormous amount of energy to stay up there on point. But when you get it right, where you're perfectly balanced, that all goes away. It's easy to stay there. That's what they all say. It's easy to do.
I mean, when I was going through junior college and I took my statics and dynamics class, I always wondered why, if you go look at these high towers, these broadcast towers, if you go look at the base of them, you'll see they come down to sort of a point, and they'll have three legs, three guy wires off the top of these things, and maybe several sets of these 3 wires. And then you're like, dude, that seems a bit weird. Ain't that going to be unstable? But once you look at the math and how the physics work, and the way those vectors work, there's a vector that's doing nothing but poking that thing in the ground just as hard as it can, and the other three vectors are coming off at 120 degrees apart and balancing that to zero at those different points. And so once I knew how to quantitatively do that, when I saw that before, I'm like, dude, that makes perfect sense. I mean, the first time I saw it, I was like, dude, wouldn't you have a big old base so it'd be bit nice and big and stable and that kind of stuff? Well, in this case, the physics won't allow you to make a big enough base to make it stable that way, you know. But using physics against that problem, and when you understand it, it's like, dude, that's like genius. Whoever thought that was amazing? Oh, that was somebody, you know, a long time ago that I'm still learning from. So. Anyway, I didn't mean to take over the conversation.
I don't know if I posted this to the list or not, but I had found a link to this guy who had a triple inverted pendulum and could take it through all the different balance states. Did I post that?
Yes, you did, and that was amazing.
Wasn't that not if y'all hadn't looked at it, I could put it in the chat here.
Yeah, go ahead, David, because I'm not sure I saw that.
That was amazing. I mean, it's got 3 links, and all 3 links can stand up, or just 2 of the links, or just one of the links on the pendulum, depending on how he jostled that thing around. He's only dealing with, you know, one axis of translation on there to make that happen, but it was really amazing, and it was just dead on, rock solid when he did it too.
Did a link just show up?
Yes, we got it.
Harold, you know what it reminded me of? Having all those, you know, multiple joints that you're trying to balance at once. I'm seeing these Chinese acrobats where they had this deal where, you know, the guy on the bottom is holding like one leg of a chair, and then balanced on top of that chair is a stool, and balanced on top of that stool. Mm-hmm. And of course you have to move in the opposite direction, and you have to move more. And I was just stunned by the whole thing. We saw a group here, and after that guy got it all balanced, then another one climbed up to the top of that. So, you know, he's hanging on the side of it, and he climbed up to the top of that. And several times along the way, it looked like he was going to fall, and the other Chinese acrobats would come in like they were going to catch him. And then when he didn't fall, they'd all go like, oh, he's just hamming for the audience, you know. He's not trying to attention. You know? I never knew whether it was real or not.
I saw a thing where as far as folks that come around a lot, if you ever get a chance to go do a Cirque du Soleil that comes through town every now and then, just don't hesitate. Whatever there's buy whatever ticket you can afford to get in the showroom, because there are no bad seats the way they've got it situated. It's literally you're like a 270 degree in the round thing as you're going, and everything is just right there in your face. And so to that jointy thing you were just talking about, so you've seen the cats that will come out with a cylinder and a board, and they'll lay the cylinder down and put the board on top of it and do one of these seesaw things, right? You've seen that a bunch. Okay. This guy, and then at the very end of it, they may do a cylinder, and then another cylinder, and the board on top of that, and it's really wobbly, and the guy will do it for like, I don't know, a tenth of a second, and everybody claps and yay. No, it is an impressive thing, right? This guy got up, did the one this way, and another one that way, with spacers in between them, so you had height between the joints. Put a board on top of it, okay, and did that. Oh, I forgot to tell you. He had all of this on a swing in the middle of the stage and started swinging with the thing, doing one of these things while doing all that. Figure those joints out and how much calculations and things have to do. It was the most amazing thing I think I've ever seen when it comes to that stuff.
Did that link show up in the chat?
Yes, it did.
I didn't label what it is.
Yeah. Well, you can do, David. You can. You just write another one.
Okay.
Yeah, because I'll go through I try it on the chat. Sometimes I try to do some editing.
Yeah. So I haven't seen the horse show, but I've seen a lot of them that come through, and I've never been disappointed. So if you ever want to see something very unique, and sometimes it's a little expensive, but it's just
How
it's
do you
theater in the round. It's amazing. It's
How do you
truly
spell
amazing.
pendulum? P-E-N-D-U.
Just get close, David. I'll fix it.
All right.
Don't worry about it.
I don't know. The internet's forever. I don't want to look stupid.
Yeah.
Well, David, let me tell you, much like myself, it's a little late for that.
Yeah, probably true. Probably true.
Okay.
All right.
Now what's the next most important thing I need to do? I'll be quiet.
Okay. Hey, Ray, you said I saw you pulling up a thing. Are you going to go through your, let's see it. You got it hooked up? Oh,
We need some audio for Ray.
Ray, you're muted. Ray, you're muted.
Everything you just said, we didn't hear.
Okay. This is the air tank. I'm kind of following in your footsteps, David. Instead of a leaf blower, this one is a, targeted,
Oh, great, great.
yeah, kind of like an air blaster to blast the cans. And so I got the solenoid in and the fittings, so that's on. And, of course you have to have a pressure valve because you don't want to go over the pressure that the tank's rated at, all that kind of stuff.
Picky.
Schrader valve to fill it on the end here. That's a tank drain in the back. Anyway, that is going to sit on this frame. It's going to basically sit in here in the middle.
Oh,
So I've
that'll
got a,
that'll look awesome.
So, it's similar to another platform that I have on the table here. It's an ESP32 with a RoboClaw motor driver, which makes it really easy because you give it a command and it figures out all the motion profiles for you. So,
what is the cans? What is the scheme? What is the technique by which you're going to locate and then blow cans into the bowl?
Well, the 6-can and can soccer, I'm using it's a Pixie cam to locate it. I'm going to grab the can with this claw.
You're going to grab it.
On it.
Ah.
And basically orientate it to the goal and then hit the solenoid for like a fraction of a second, just enough to get it to go down the soccer field.
I had pondered this same question because, it's easy enough for the robot to know where it is and where the goal is.
Yep.
So if I could grab the can, then all you got to do is rotate in place until you're pointed at the goal and fire off in my case, leaf blower. Okay.
Right.
If you don't have a gripper, which I don't, then the next step would be you have to actually know where the can is and calculate where the robot needs to be, right? You're not going to move the can, you're going to put the robot. So you have to draw a straight line between the can and the goal and put the robot on,
behind it. Yeah.
Yeah, along that line. So I worked on that for a while. That turns out to be non-trivial.
Probably not. Yeah. So this I think was, grab it, orientate it.
So I had pretty much decided that if I wanted to pursue that, I needed a gripper, or at very minimum, something that I even thought about, since this is can soccer, just some little like legs that stuck out so I could drive up to it and maybe hook it and swing it around into position.
Yeah, yeah.
Okay, so I need little hooks on the end of these things, and I thought little doll shoes. What do you think?
There you go. I'm sure Ron's got plenty of those.
So I have a request for Ray. When you test that the very first time,
Say that again?
When you test that the very first time, you have to show us the video, because I'm really kind of interested if Newton's laws take effect, and shooting that blast of air is going to push your robot back.
Oh, I'm sure it'll push it back a little bit. I think it looks
heavy,
actually
so I
using
don't think so.
The Bernoulli principle. It's kind of like if you have a jet of air or a channel of air, it can actually carry things much further.
Like one of
that's
those
what's going on with the nozzle.
Like one of those vortex cannons.
Kind of, yeah. Yeah, but this is the blast is like it's a fraction of a second. It doesn't have to be very long, and I've tested it out. I can shoot at least 6 cans, 10 feet, with 90 psi in the tank. So,
Well, when-
which is, pretty safe.
When Doug was first encouraging me to think differently about the can, I tried a whole bunch of different things. I tried something like it would be like a golf club, that I could whack the can with, but it was totally uncontrollable. And I tried a vortex cannon. I made one out of a big cardboard box, and I could knock the cans over all the way across the room, but I couldn't actually move them. They didn't move along with the vortex. All I could really do is knock them over. I was never able to blow them, and that's why I eventually settled on the leaf blower. I did find, I fire the leaf blower in little short bursts, but the big motor on that thing torques the robot sideways when I fire it.
Oh, does it
Eh.
twist it sideways?
Yeah, like that.
Huh.
And so I actually stuck a cheat in the code that has to be applied while you're running the leaf blower.
Oh, to keep it from twisting. Yeah.
Well, to inform it that it's twisted.
Oh, okay.
Yeah.
Yep. Anyway, so I'm working on that one, and then I have, this is more of a conventional approach. I've got 144 millimeter wheels on it. I think these are 200 RPM motors, which are faster than the ones I had on the other one. And, a 4S battery, so they're 12-volt motors, but it's working closer to 15 volts. And RoboClaw and an ESP32 on it. And I've got all the, all the motion stuff worked out, as far as being able to move a certain distance forward and, go in a straight line, turn the correct amount, like per degree of rotation. So that all works. I can actually show it to you if you want to see it. But it's going to have the same components on it as the other one does. So I'm actually going to try to get this one going first because it's a whole lot easier to carry up and down the stairs versus the other one.
Ray, you use ESP32s on all these. Do you use a Wi-Fi or their Wi-Fi on all of them? And is that how you develop? Do you actually plug in a wire when you're developing?
Yeah, mostly it's, I'm still kind of using the Arduino IDE. I played around with Platform IO a little bit, but the code has been written in.
When you download the code and so forth, do you do that through the Wi-Fi link?
Oh no, there's a USB.
You do that through a wire.
Yeah. But like for telemetry on the outdoor robot, I can use the ESP Now protocol and send it to. It's a unit. This isn't the exact unit, but it looks similar to that. It's an LCD touch screen that also has an ESP32 on the back of it. So that's a capacitive touch panel.
Wow.
And I have it's just a cell phone or whatever battery pack, that you can charge up and run your cell phone off of, or charge it back up. And I use that to power it. So it's got the ESP32 Now protocol running, so I can just kind of look at my wrist and read kind of all the telemetry data, battery voltage, pretty much any parameter any variable that you have, you can throw it out to that screen if you want to. And so it's pretty handy. It's you're not chasing your robot looking at this little teeny screen that's moving so fast that you can't make it out anyway. So so that's kind of nice. But anyway, so I'm working on the two things in parallel, and should be entertaining. Either way it works, you know.
Ray, I was trying to troubleshoot a problem on the big 6-wheel outdoor robot. I guess that's not so big anymore, but a problem I never actually did run down. That's one of the reasons I decided to switch to the ARM processor. But what it found me doing is, it's got a XB connection, and then I had the USB XB plugged into my laptop, and I'm now down at the city park, following my robot around the city park, collecting, telemetry and watching the screen, which, as I say, is not optimal. But I imagine that park is surrounded by people who have, smart cameras that would gladly offer me a little of their bandwidth.
Yep. So you don't see camera people walking up with their phones, watching you or taping you or anything, right?
Not yet.
Not yet. Or you could do like Kareem had a I don't know, kind of a shoulder belt kind of thing that, yeah.
With a tray that hung off.
And a tray, yeah.
Well, Pat, do you find yourself doing this, chasing your robot around with a Wi-Fi connection and a laptop?
I had set up one where I was using a Wi-Fi connection just in my pocket. So a little travel router that has a battery built into it.
Okay.
And the only thing that was doing was connecting my laptop, a kill switch, and the robot together, so that I could walk out and be, in the middle of the field somewhere and still at least have Wi-Fi control and feedback.
What kind of distance do you think you got?
Outdoors, I
Yeah.
never got farther than 20, 30 feet away from it, which was never an issue. But outdoors with Wi-Fi, I'm guessing 100 feet easily.
I will say that at one time my sensibility was that I wanted to be able to send the robot out away from my range of vision. Send it out to do things and then come back. But my actual practical experience with the 6-wheel robot, and especially being up in Colorado, is I wanted to be there and see what it was doing. I always ended up following it because I wanted to be there. I want a camera crew to follow it around and document its every movement. Now, if I had a first-person video, I'd still have to think about it.
Use a GoPro on a drone to follow it.
I'm still nervous to fly the drone out of sight. I see other guys flying them, and I can't get myself to do it. Not yet.
That's one of them I was using. It's called, where's my new camera? A Hutu.
Speaking of drones, if you watch carefully in Walmart parking lots around the area, there's a company called Drone Up, and they've got some pretty good sized drones that are doing some field testing for this drone delivery system they're working up. I went and stood behind them there for a little while, and they said, well, you can stand back here, but don't post any of these pictures. I'm like, okay, cool. I just want to see what's going on. So go be on the lookout. They'll be off the side of a parking lot. They'll have generators. They'll have a tent over the top and an area for a landing area for a takeoff area for their drone. So just be on the lookout. It's really cool. They have like 2 controls: takeoff, land, and return. That's all these guys get to do. And they got lots of data and stuff flying around on the thing. It's pretty cool. Anyway, I'll be quiet.
Hey, Pat, can you put that link down in the chat for that router you had?
Yeah.
I don't even know if you can get it anymore.
Yeah, that's fine. At least you.
Is it a USB device, Pat?
It's a USB travel power pack, but it's also got a router, access point, all sorts of stuff in it. So you can use it in a hotel. You can use it everywhere.
That's actually a good idea.
Well, when you travel for work and stuff, it comes in handy. I don't know if I can find it here. That's the software.
Yeah, the the random nerd tutorial. He got 722 feet to 220 meters line of sight, clear line of sight. So that's pretty good.
Well, and line of sight just really goes to shit when there's trees and vegetation and stuff.
Yep. Yeah, it's hard to say what it would be in the woods.
I can see the moon.
Ed, it's just 2.4 gigahertz Wi-Fi. Here's a similar one. This is the newer, updated one.
Paul, why I'm not conversant. Why does the LoRa protocol give you longer distance with less power? Is it less bandwidth? Is that what the trade-off is? I think your mic is off.
Yes, it's a lot less bandwidth. And apparently you can, I don't know how, but you can dial up more bandwidth for less distance. So you can choose your bandwidth versus range setting on LoRa devices.
So if you're willing to settle for less bandwidth, you get back more range?
Yeah.
Yeah, it's kind of I guess it's spread spectrum.
It is spread spectrum.
Yeah, so you're using,
Is it the frequency hopping type, or is it the, broadband type?
I actually think it's actually the frequency hopping. The I know you can designate I'd have to read up on it again. I was familiar with it a while ago when I first looked at it, but it's I guess they call them chirps per symbol, and yeah,
That's what CPS
stands for. I don't remember what it is, but
I
basically,
thought CPS was replaced with Hertz.
Say it again.
I thought CPS had been replaced by Hertz.
CPS.
Chirps per second?
Oh, chirps per second. Don't know. It's I'd have to.
When I was a child, it was GPS, but when I got to college, they told us it was Hertz.
Yeah.
Anyway, knew it at one point, but have since forgotten how it worked.
That's okay. I can Google here, but I appreciate the input.
Probably wasn't.
Unless you're doing video, most of the things we want to do with our robots is low bandwidth. I would think, even if you're doing, telemetry and sending back control and so forth. Plus, it gets us accustomed to what NASA is going to require when they put our robots on Mars.
Oh yeah. So what I forgot to say about this little gadget is the Sidewalk is offering this to developers. So I signed up as a developer, for the developer program, and they sent it free, and it's a little thing that sends a ping out. So it's ring branded, but it's basically a Sidewalk peripheral, and it sends a ping out to the application server every once in a while with its GPS coordinates. And so the idea is it's for developers to walk around town or drive, whatever around town, and see if they really are getting coverage consistently all around the region of the area of interest. So I somehow don't have access to my Sidewalk account. Otherwise, I'd have something more interesting to show you. But maybe, I put in a ticket. Maybe now, by next time, I'll be able to like show some places I went with this thing and where it tracked me.
That'd be good. One of the things I had, Paul, that I was a little, the Apple has their AirTags,
Right.
and that's doing something where they're borrowing information off of other Apple phones and
Exactly. So
stuff.
it's that exact model where, as an iPhone owner, you agree to give up a little bit of your bandwidth for AirTags to bridge through your phone to the Find Me application.
Mm-hmm.
So it's that exact thing, but maybe more general purpose.
Mm-hmm. Yeah.
Well, this is sort of like a top-down rollout of a mesh network, is it not?
Yes.
I mean, I'd always imagined that those things would grow bottom up,
Well, it might not be exactly mesh in the sense that mesh, I think, usually implies station-to-station hops down a chain potentially before it exits onto the internet. And
I see where this is just actually looking for the closest access.
Closest access point. So it's more of an access point model, I think.
A close access.
Yeah. So what they basically did was they put access points for the Sidewalk network in everybody's home for the last 5 years, and then said, "Hey, look what we've done! There's this fantastic network. It's now available for you to use. Reaches 90% of the population. It's kind of interesting."
But my point being, of course, that with the mesh network, you also have to give up a little bit of bandwidth, and the reason you do that is because other people are doing that for you, like in the early days of the internet.
Mm-hmm.
Like in the early days of what?
Of the internet.
Yeah.
Yeah, UUNet was a thing. That's how that used to work, right?
Right.
Modems, all that kind of stuff across the. Yeah, you didn't get email in seconds. You might get it in days or weeks, but not seconds.
And I remember we were on the ARPANET, and ARPANET email addresses were a string of server names separated by exclamation points that were the manually generated route that it should follow to your destination email address.
Exactly. Plus, you also got to hear the mating song of the modem, which I greatly missed. I used to sing along.
Yeah.
There was forget the name of the group, but if you're on their CD, but you had to buy the CD to see it. There's an extra bonus track called 8-in-1. 8 bits, no parody, one stop bit. Basically, that was the name of the song. And,
I love it.
And if you got in and played it, you would hear. I'm sure that David knows how to sing 300 baud, and 8-in-1 could probably decode it with his ear. But if you went and played it and did an acoustical modem and played it back in where you could do it, it actually tells a story about a thing and spits it all out. It's pretty cool.
You mean you could actually play their recording into a acoustic coupler and it would return ASCII text?
Return ASCII text.
That's a great idea. I'm waiting for the one. You guys may remember a year or two ago that there was some controversy about a television ad that was triggering people's Alexas, their Google Assistant. It was supposed to, and it said something like, Alexis, Google Fritos or whatever it was a commercial for. And then the people sitting in their living room had to listen to a commercial coming from their own device. And I don't remember what happened, if there was some legal action, but I haven't heard any more. But I thought, what a great idea. If we could get them talking to each other, that would be the best.
You know, I hate to be a jerk, but yeah, no, I don't hate to be a jerk because, well, I'm going to be a jerk. Hey, man, how you do? I walk in somebody's house. Hey, how you doing, Joe? Hey, Alexa, order 200 pounds of play sand. You know, and
Well, those are tiny. I had no idea. That looks like a teensy or something.
Oh, this, yeah, it's one of the this one is actually based on the 32U4, but they have ESP versions that are similar to that.
Can you put a link into that, Ray? Into the chat?
Yeah, let's see. Okay.
That way I don't have to read.
Let's see. Yep. Yeah. I can get the link in a second. But,
$40 for 2 modules.
Yeah.
That seems worth at least experimenting with.
Yep. And they've got a plug on the back so that you can run it on a lithium-ion battery. It actually can charge the battery through USB, which is kind of nice. And the received signal strength indicator was pretty handy. So what I did, I'm gonna jump ahead here. This is a map of my property, and this is where the house is, and this is where the metal building is. And let's see, from about here it's about 1,200 feet, and this is about 400 feet wide. And so I went kind of all over, got in my wife's car and drove out on the road here, and I was just trying to figure out, how much, or basically what the received signal strength indicator would be.
So you're watching that indicator while you drive, or are you logging that?
Well, actually, let's see, what was I doing? I was having my wife watch it while I was driving the transmitter around.
Boy, you've got a good wife.
Yeah. Anyway, so I had the receiver in my office. So if I was just outside, well, this one I think was actually, yeah, I think that was just outside of it. So kind of catty corner is the guest bedroom. I'm in the back on the east side. Back on the west side. This is the front on the east side. So, it lost quite a few dB just doing that. And then
those RSSI numbers are in decibels.
Yeah.
So it says in car is 98 dB down, the last one.
Yeah. So that was actually, the receiver was here, and I had the transmitter like up over here, and that was, I think, the lowest receive. Well, yeah, in car was, but the thing was just sitting on the passenger's car seat, so had to get out of there.
But it still worked.
Oh yeah, it worked fine. Let's see, was that one? Yeah, so they're actually using more, like you have the option, the coding rate, you can use 5, 6, 7, or 8 bits to encode 4 bits. And there's, I think the spreading factor, basically there's like, I think a set number of frequencies in the 2 bandwidths that you can choose, as far as I remember anyway. So it had a pretty short preamble. There weren't, you could have it as 8 bytes if you wanted. I think you have the option. Well, yeah, you just had the option to use CRC or not on the individual packets. And yeah, that one had pretty good information. This link. and Andrews Spice, I guess is his name. He has a bunch of YouTube videos on LoRa. If you know, he's a good source of information for lots of things, I guess. But initially had a setup like this where this I was using an HC12 module, and it didn't work that well, and basically gutted this and went to the LoRa module, and it worked very good for I was just sending 2 joystick readings basically, and seemed to work pretty good for that. Yeah, I think that's all I had. I still remember all the intricacies of how they basically use a lot more bandwidth than what you'd need to transmit a set number of bits.
Your results are really interesting, Ray, especially the -98 in the car at the far corner of your module of your property, and they mirror a test that I did at Lockheed, where it was very similar situation. We were in a big parking lot that kind of had sloped over a hill, and it was probably 1,000 feet from one corner to the other, and you would actually drop below line of sight.
Yeah.
And we found that we would lose communication from opposite corners of the parking lot when we didn't have direct line of sight. And I was thinking to myself, well, I'm not so impressed for something that's supposed to have 5 miles of range. And then I was talking to one of my buddies who has I don't know if he has practical experience, but he was the one that was telling me about the bandwidth versus distance trade-off. And you can really get a lot more distance if you slow it way down. So I don't have any practical experience, but your -98 dB at 1,000 feet kind of echoes what I saw with a kind of out-of-the-box configuration that we were playing with. So I wish I had more like practical experience.
So is your wife pretty cooperative? I mean, you can be the driver, and she can be the writing down all the data and in air conditioned comfort.
I have to promise a lot.
Yep. Anyway, it seemed to work pretty good. The ESP Now stuff. I mean, I kind of like what David was saying. I kind of like to watch what it's doing, so I don't know if I'd ever test it to see how far it could actually go without watching it. So always be close enough to see it. But anyway, this is the other platform. I don't know if I showed it to you. It's got the big wheels on it, just like Mr. Gibson has, and I guess I did show it to you. But with the other platform, the motors, I think the fastest they'll go is like 100 RPMs. So these motors are twice as fast. The other wheels were, I think, 98 millimeters in diameter. These are 144. You can get a set that's actually 200 from Pololu. And he has those really large machined aluminum wheels and on his, and that's partly how he gets his speed. So and I actually put that other platform together. It's been 8 years ago, and made upgrades to it, but the one that I used for 6-can and can soccer, but hadn't there's certain fundamental things I couldn't change, that couldn't drive the motors any faster. I was using, he's also using a mechanical LiDAR. I'm trying to get away from that now and do things just with two large color blobs at the either end of the goal. Oh, Paul, had you ever used April tags? No? Okay. Yeah. Kind of played around with April tags, but I can see these color panels a lot further than I can see the April tags. And I even blew the tags up a little bit. These are, you can print them on like an 8.5 by 11 sheet of paper. This is actually 11 by 17, so had them blown up a little. And you can get angular orientation and distance from it based on what it actually highlights that symbol in the middle, and that's a certain size at a certain distance, so many pixels, and so you can correlate distance with that, and then basically where it is in the field of view of the camera, you can get the angular information from that, so you can get the angle and the distance based on the tag, and it recognizes the tag as it's this tag family, and this tag in that family, basically. So there's the different families have different numbers of tags. There's two different tags in the same family. Tag 1 of 36H11, and there's actually tag 0 of another family, the 16H5 family, and
Ray, are you decided not to use that?
No, I can get much better range out of sticking those
color
basically.
blobs?
Say that again.
And you do the same thing, you know how big the color blobs are, so you know how far away they are?
Well, I was just, I know how far apart they are, and just by like triangulation, I can figure out, where the center of the goal is, and I can see those, at the opposite end of the soccer field, at 10 feet, and I actually have those, color tags, I guess, for lack of a better description, 3 feet on the other side of the goal. So I'm actually being able to see it 13 feet away, whereas these I can only see about 5 feet away right
Really?
now. Yeah, at this size.
At that size. And that's on 11 by 17 sheet of paper?
Yeah. Yeah, and the color tags are, a little bit bigger than that. So that's...
Ray, does it just come down to how many pixels are being mapped into that image?
Yeah, I'm using a wide angle lens, and I wanted to do that so I could see either,
right,
both tags or both color blobs at the end of the goal. Like if I'm running right in front of the destination goal where I want to drop the can off, I had to move the color fiducials or tags or whatever further back so I could actually see them with the wide angle lens, so they'd still be in the field of view, and they're large enough that I could also judge distance by how many pixels it sees in the blob.
Mm-hmm. Hey Ray, I just caution you. You can't have them beyond the goal. You can only have them on the side. Just so you know.
Okay, I thought
Nope.
you could have them
just
parallel with the boards, but further back.
No,
not in behind the goal.
No, I believe if you can look at the map, but
okay.
I believe your only valid is the width of the wall on the sides. Just so you know. But you could still do this with narrow. Instead of trying to do such a big block, you should just be able to do like a column, They don't have to be round columns. They just need to be narrow and
Right.
tall.
Yep. Tall enough so I can actually see them.
Hmm.
Yeah, I thought like if you've got the two sides, they're 10 feet. I thought if you extended
Take a
lines
look.
on
Take
either end, you
no.
could
Take a
go-
look. I might be
Yeah.
wrong, but I believe
Yeah.
that anything behind the goals is you can't do it.
Can't do it. Okay, I'll
All
look.
right. Take a
What,
look. There's,
what about the case we talked about where you have something mounted on a pole basically in the corners? You know,
if you have it outside of the arena, at the corners of the the two walls that are on the side, that'd be legal.
that would be legal.
Yeah, on outside, you
Yeah.
can't have it inside, but yeah, on the outside. But if you go beyond the plane of the goal or the other sides of the box, then I believe that's illegal. But it's
Okay.
there's a diagram. I just can't remember beyond. That's what I thought it was.
Yeah, I'll look it up.
If those two poles had some sort of beacons on them,
It's perfectly legal.
okay, suppose those two poles had, instead of beacons, they had cameras on them and microprocessors, and they were broadcasting to the robot its position. And
You
the position
can't.
of all
You
the
can't. That I wouldn't be opposed to it, but by the rules, since you're getting data, you're all of the computing has to be done on the robot.
Well, in the case of just to play the devil's advocate,
Yeah.
in the case of the poles with beacons on them, it's not all being done in the robot. Some of it's being done by the beacons, right?
Well, it's not communicating information.
Well, it is. It's flashing a LED. It's sending
Yeah.
a signal
Yeah.
to the robot.
Yeah. Well, it's not. You'd have to read it.
Okay, so basically, it would come down to how much information the beacon is sending.
Well, I mean, obviously, if you wanted, I don't really see advantage of it, but anything you can do with having LEDs flashing around that doesn't have any computing power, that doesn't have anything, anything that's sending data, actively sending data back, I don't see any advantage to it. But if you wanted to have a flashing light, that'd be fine.
No, I was just trying to see where the boundary was about how much
Yeah.
information the
Yeah.
beacons could
Well,
send to.
we've been talking
robot.
because you haven't been, but with Kareem, his team wanted to do something, and I discussed with him the idea of a completely open class. All right, and where otherwise anything goes, but the intent is that you would get the 6 cans in the goal. The only rule was you can only handle 1 can at a time.
Boo! I hate that rule.
Yeah. Well, I mean, sweeper bars and stuff like that aren't very
Yeah,
interesting.
your leaf blower attack is not going to work too well with just 1 can at a time. I mean,
Well, no,
actually,
I'm
that
pretty
wasn't too bad.
I'm pretty sure that rule was come up with specifically with me in mind.
You're right. Hey. Okay.
Yeah, I thought you
Ray,
could stick
Ray.
everything here.
Okay.
Like I wanted to stick them 3 feet over here.
Yeah.
3 feet from this.
No, it looks like you're right, Ray. Like I said, for some reason I thought there was another line, but from that it just says you can go anywhere on the sides.
Right. So if I stick them back here, 3 feet back,
Yeah.
I can see them from here and all the way, like I think I'm 2 feet away is as close as I can still need to still see them at.
You'd have to watch the 8-inch wall. I would imagine that would become an obstacle if you got too close. I don't know.
Yeah.
But it's just something to think about. No, you're right. If according to that, you can put them all the way to the back.
Yep. Anyway, so.
Okay.
But,
Cool.
so can I start the auctioning for the bid of highest bidder has me wear a bright orange shirt versus not wear a bright orange shirt
Yeah.
as I'm walking around. Just saying.
Actually, I think that if wearing you, for example, I believe we had a rule in there, not so much on six cam, but on soccer, that you couldn't have the color of you couldn't use orange color for your robot parts.
And in full transparency, last year that was not an intentional thing by me. I just like the shirt.
Yeah. Well, like I say, that's like we've had poor guys that have lost out because of orange tennis shoes. It's known to be a factor.
Oh yeah.
Yeah.
Yeah, I remember the one time that we went to the Frontiers of Flight Museum, and there was a woman astronaut in an orange jumpsuit. She walked by our booth and set the little robot out there, and it happily chased her around. So.
Yeah.
I also discovered if you're going to take your outdoor robot to the park, you want to be sure that they're not doing any construction down there, because they have their own orange cones.
Yeah.
Yeah.
And they really look for people bumping their cones. They really don't like that, do they, David?
Well, down at the park down here where we ran the competition a couple of times, they put up this orange plastic netting,
Oh wow.
around all the trees. So it was just like this orange nightmare trying to get to the cones. Just orange everywhere.
Anyway, so I hope to have at least one robot, but maybe two.
No, I really want to see really want to see the air blaster. I'm just going to call it that until you give it a name. So that.
Yeah, I was gonna write on it. Basically, club blowhards, and the first one would be, what's his name, Gibson. All the smack talk, and then the second one would be Master Blaster. It would always make him the biggest blowhard. So.
Yeah. It's not blowing if he's winning. So the real trick would be to beat his time.
Yeah. I think I've got a pretty good shot at it. I mean, if I don't have to carry the cans all the way back to the goal, it's.
Yeah, that sounds like you should be able to just go to a can, blow it, go to a can, blow it, load it. Saves you a lot of time.
Mm-hmm.
Here's what happens. Those cans are not soccer balls. So as you probably discovered, they don't travel in straight lines. And depending on how far you are from the goal, I found that there's a large likelihood they'll land in the corners. And so I actually ended up having to program a special go get cans out of the corners routine, where you go down in there and stand off at an angle and blow hard into the corner and try to blow out whatever is there far enough that you can then see it.
Yep.
Yeah, but Ray's got an advantage. With his design, he can always center up. He still saves time. If he just, let's say he picks up a can and moves it to the center of the goal, and then hits it, he can try to minimize the impact if he's got any control at all. David, he might, his.
I'm just saying they don't always,
Yeah.
Yeah, they may not, or may hit the side of the goal.
Always go through the goal.
Yeah. But he's got it, with his gripper, he can tee them up, and he can position them. So it'll be interesting. It'll be interesting to see.
Yep.
Well, and maybe there's some minimum angle you'll define that says, if it's greater than this angle, you need to grab it and move it a little bit before you try to shoot it.
Mm-hmm.
Yep. Kind of what I found is if, I'm like 3/4 of an inch from the top of the can, and And the can be a little off center either way, maybe, I don't know, at most probably half an inch. It actually tends to, like, the can doesn't drag along the ground. It actually flies through the air. It's kind of like if you hit the can. I don't have a can here. If you hit the can, close to the top edge, it just kind of like tosses it. And there is a little bit of an arc, and then it will hit the ground and either tumble or fall over and roll. But
Yeah, it'd be interesting if you took your nozzle and maybe tilted it slightly upward too a little bit.
yeah,
I mean, I don't know. You just have to find that out for
yeah.
testing.
That's why at this point it's a piece of soft copper pipe, which I think I can twist around.
Well, it might be interesting if I ever again get this machine working. We could have a special demo contest in which we replace the cans with orange balls.
Orange balls.
Orange balls,
Okay. Yeah.
where they would
Try to
roll.
roll them in.
Mhm.
Yeah, because what you're describing, my experience is that when the can falls over, and as you say, if you maintain the stream of air, it can sometimes tumble end over end. But
Yeah.
even then, it's likely to fall over and start rolling, and
Mhm.
and it's not likely that the vector that it happens to fall over is pointed straight into the goal. It's just as
Probably.
likely that it's not. One of the
Yeah.
things I found that helped that a little bit was to go ahead and blast the whole way until it's through the goal. I think that high velocity airstream has kind of a boundary around it, if you know what I mean. And so that would kind of push the can back in if it started rolling. So you might try that.
Yeah.
Rather than just giving it a punch, I actually blasted it all the way in.
Oh, well, they have so much air, so I can't leave it on forever.
Well, the downside of that is that I often knocked over other cans in the process that I wasn't looking for.
Oh yeah. I guess it depends on where they're placed. If they're anywhere in the center, it's probably gonna
Are you gonna
hit them and not go in the goal.
right now? You got a piece of pipe, just a pipe. Are
Yeah.
you going to attempt to 3D print some nozzles or something to try some ideas? Like fans and.
Yeah, there's a restrictor on the air tool. I could either try to narrow down the piece of pipe, or like with a knurling tool on the lathe. That's an idea. And it actually might help the solenoid because if you have some pressure in the line on the other side of the solenoid, I think it can switch easier and faster. So
Cool. Well, so we'll get to see.
Yep.
Okay.
Fingers crossed.
So, I have a question. I don't know if I have shown this to Harold or not. So, Harold, are you online? Take a look at this. Tell me if you've seen this before. So, once I click on the right thing. So, Harold, does this look familiar or not? So you might
Yes.
look at it. This
Yeah,
one,
that looks familiar. That looks familiar.
because it, talk about having the battery on top, amongst other things, and the fact that why you put the battery on top. So that's why I was wondering.
I've also thought about on this thing is essentially a bucket where you chunk stuff in it for this breadboard bot. And
Right.
I'm thinking that maybe what I do is I redesign the holder to still take breadboards and things, but then make sure I get the battery all way on top, not kind of off the
Right, I
back
noticed.
side of it and a few other things.
Right. I mean,
And so we just
if you look
redesigned
at-
the whole holder in
if you
general.
look at this picture, notice he has the battery on the very top center. Then he has the controller in the middle. In other words, the lighter stuff on the bottom. And he emphasized that fact here about that higher center of gravity means
I got this weird idea in my head, and it's probably totally wrong, that
so,
all these guys get up. They every one of these things that I've seen mostly. They're
Okay. Well,
using
this
something.
one looks pretty well descriptive. I mean, to me, he,
Yeah,
look-
in fact, I started doing this adjust the K and the P and then
Okay.
the I and the D and all that kind of stuff. I do remember seeing this to say, how do you do
Yeah.
that, right? And
because this one is very, he goes into a lot of detail. It looks to me like pretty descriptive. And then, there's the code.
yeah, and what I was going to get to the code, and maybe this is me being, I don't know, a rebel. Yeah, rebel without a clue. I'm looking at all that code right there, John, is probably
Yeah.
something from 15 years ago.
Okay. Well,
I think we got to be doing something better now. Just,
all right. Well,
that's kind of what
after the contest, I'll start. Yeah,
No,
see,
I
built the one, but I haven't gotten it finished yet either. So
I truly appreciate you still looking and bringing it up, John. I truly do.
I'm just checking on this one because this one is pretty precise.
And yes, I was actually using that. I got that as
Okay.
I do remember that, and I do have that link that I've been referencing for doing these things. And yeah, and the other thing is, this is part of my rebel without a clue. I believe that there is a balance point. Almost all these I'm saying is, okay, get it balanced as you're building it first, and then do these things. Well, why am I doing these things? I don't know, because somebody else told me to do these things. That last part kind of bugs me. But I think anything can balance because we prove it, right?
Yeah.
So at that point, it's a set point that where I want to set my point of my angle of the slope of the curve. And at that point, it should balance regardless where the balance is, right? It may be harder and I'm probably doing this to myself, less, but if it's a little off kilter, well, it doesn't stand straight up, but if it balances this way, it should balance that way.
Harold?
Get perfect
Harold,
balance. you can.
I have a question.
Okay.
Do you have wheel encoders on this robot?
No, which is a problem.
Okay, well, this is going to sound simplistic, but sometimes deep truths are simplistic.
Okay. Lay it on me, Brother Anderson. Lay it on me.
The robot is balanced when the wheels stop moving.
Whoa, get out of here, man.
It doesn't matter what the angle is.
Yes.
Whatever
Yes.
angle it balances at, once it's balanced, the wheels stop moving.
It's balanced. Right?
So the way I have approached balancing robots, I don't know how to do it without wheel encoders.
Okay. And that might be my total downfall of the whole thing, right?
Yeah.
They don't use real encoders in this one. They talk about degrees, like 173 degrees.
Well, how do they know that? Oh, they're using the IMU.
Okay.
Yeah. But I want to say the one reason why all of the code looks similar is because they all use the MPU 6050. If you really want to do something different, then you don't want to use the MPU 6050. What do you use, David? What's on yours?
The processor?
No, the
the
IMU.
Oh, that's one of those microstrain. It's a single axis device.
Okay.
It consists of a 2-axis gyro and a single axis accelerometer. No, I got that backwards. 2-axis accelerometer and a single axis gyro and a Wiener filter. So it's not really the same as an IMU.
Well, this guy uses a MPU 6050.
Yeah, and that's what
Yeah.
I'm saying is that's the most popular IMU because it's inexpensive and easy to get. And
looks like
they
that's
also
it.
have that dump library, which
Yep.
provides you with some Kalman filter information, a DMP filter. So, I mean, if you're using that IMU and you're using the dump feature, then the code's going to look alike, pretty
Yeah.
much.
Let me also add, and I'm sure this is something you've come across, Harold, but just generically for a balancing robot, there's actually two big problems to be solved. And the first one is sensing the angle.
Mm-hmm.
In my first balancing robot, I actually sensed the angle with a potentiometer with a little feeler that rubbed on the floor.
Oh, okay.
And that was actually the most accurate one I've ever had. When I got the first IMU to work, I compared it against that to see how well it was working. So that's one whole, huge problem, accurately sensing the angle. The second problem is then using that information to balance the robot, which is the
Mm-hmm.
tuning the parameters and all that sort of stuff. And I know a number of people that I've tried to help get balancing robots working basically made that one big problem and were never able to solve it. The robot's not balancing. Which part of that should I be working on? Should I be working on the sensor, or should I be working on the algorithm that uses the sensor? But both of those are big problems. They're separate.
That's kind of what I did with all this stuff. I broke it down into the smaller and smaller bits, and then finally, like this, the one that he's showing now. Hey, John, could you bring that schematic back up?
I keep trying to scroll this page up and down.
See, he's got that. He has a 9-volt battery going in the L298D. I'm sorry, L298N. That motor controller board. Guess what's not going to work very well? Because that 9-volt battery does not have enough juice to power those motors to go very far, very fast. And like Mr. Anderson said, once it's balanced up, it's okay. But you need something more than the 9-volt battery.
Yeah.
I run mine 24 volts.
Yeah. Well, see, there you go. Something more.
And you notice he's not showing a 9-volt battery on his actual build either.
No,
Yeah, he is. It's at the very bottom. It's down at the
Look on
green.
the top.
No, it looks like he's got 6 volts.
No, he's saying both. He's got a 9-volt on the bottom panel, and he's got looks like.
Oh yeah, you're right. I see it now.
The 6
I
volt
look on
power
the
and everything
top.
else, right?
So.
Yeah.
And so what we literally went through every piece of this thing.
He's
Like,
using the top.
How much juice do we have? How much this do we have?
He's
is this
using
gonna be
the
enough?
top to run the motors. That's the whole point. He's running the motors off this top tray. The bottom one's just feeding into the.
That's not what he shows on his schematic. I didn't see.
Well,
Pull that again. See,
I
he's got the
think
9-volt running right into the motor controller.
he goofed them.
Yeah, that's so. And you're probably right. You're probably right. He's probably using the 9-volt to power the.
Actually, no, you're right. He's running the 9-volt for the motors, and then 4x8, that's 6 volts. Okay, so he's running 6 volts into the board. 6 volts into the board and 9-volt pure to the motors.
Yeah,
I think he's got that backwards.
Yeah, he's got it backwards.
Yeah.
Because that's just not going to work.
Yeah, but don't you want more voltage to your motors than you do your board?
You want more current capability.
Current, it's what you're saying.
Yeah.
Can't go enough current.
I don't know what currents of 4.8s are. So.
Yeah.
Okay, but in any case, he makes a point though that rate-wise, he wants as much rate on top.
Yeah.
So
I think he did a pretty good job, because I remember reading this and saying, "Hey, I need to hold on to this and take care of it."
No, the center mass higher up, the better it is, seemingly.
Yeah. So I mean, we pulled this thing all up. In fact, we fired up a motor one at a time, and made sure we could start the motor and stop the motor at various speeds and stops. And literally, we went through each section of this and figuring out how does this work on what we have going on through my streams.
Okay.
And it's to the point where
my
left motor works a little bit differently than my right motor, so I've got 2 different methods, so I can control the mapping. If I tell it to do, I get a plus or minus 255 on this thing. If I tell it to do a plus 10 on one, it actually turns into a plus 11 on the other, just because of because I do some mapping, because of the way the motors are slightly different, and I still don't have them close enough, but they're more close than they were. And then we also did the same thing with the figuring if we're balanced or not. Literally, we pulled the 60-50 up, and we did nothing but do that code, run through the stabilization stuff, so we have a good configure, so we can set the offsets on it. And what we learned, we went through all of that stuff to to make sure that we understood each component before we started throwing them together.
Okay.
And it's
So
Hey,
what map was
John, go back up. He talks about the power, and his power is consistent with his schematic. So I don't. That seems a little weird. I
that thing's a
stop
little
right.
weird.
Yeah, he says he has
there?
6 NiCad batteries for powering the circuit board, and then he only has 9 volts powering the motor driver.
Does that mean powering the motor driver board?
Well, that's the way he's got the schematic driven.
Yeah, providing power to the wheels.
Yeah. Now,
Now, Mr. Anderson, I'm going to take his little thing. Now, if that robot never gets out of kilter very much, maybe that's enough. But if it
9
gets out of
volt
kilter very much at all,
batteries suck. I mean, they
yeah, they do
just.
suck.
I mean, they're not. They were.
Not very powerful.
No,
But the little motors probably aren't that powerful either, right?
no, they're the little yellow 3 volt motors.
Right.
Yeah.
Also, he may not be intending this thing to run for very long.
Well, that's the thing.
Yeah.
I'm thinking it doesn't run that long.
Does he have any video or anything of it? Actually,
Let's see if he has.
What's
I'm
he
always-
say? He says something there about a jumper to 12 volts. What's that?
Well, let me slow down there. Okay, so
That's
there's
if you really want
Whoa,
it to
whoa,
work.
whoa, right there.
there's now the
Oh, if you're planning to use more than 12 volts.
he's running 9 volts to that L29080N and using its regulator to power his Arduino.
Okay.
right.
So he needs to feed it 9 volts so he can get a good solid 5 volts out.
Right. That's true because it's
Why?
got.
Yeah. That's what he's doing. I've got one of those right here.
So
Yeah.
what's MapLab? Because you said something about engineering use software like MapLab to compute the values.
Harold, I will say, having looked at their algorithm here, that it's very different from the way I do it. I think I sent you my algorithm one time, but basically here he's got a standard PID controller, and that's not what I use. What I use is a controller that reads the tilt angle. We can call that a P, and it reads the derivative of the tilt angle, which basically is the acceleration.
Yeah.
Okay, which we can call D. But then I also take the position of the wheels, which is another P, and I take the derivative, so the wheel velocity, which is another D. And it's those 4 values that I combine.
So you don't have just 3 values, right?
Yeah,
Then?
I have 4 values that I combine. And that actually is slightly a misnomer because if the constant that's associated with the gain of the wheel position is non-zero, the robot will stay in place. In other words, it will not only try to stay balanced, but it'll try to stay in the same place. So if you want the robot to drive, you have to set that value to 0. So that means the robot's got to be able to balance whether that value is 0 or not.
No. Yeah. Okay.
So in the early days of making it work, Doug, that's pretty loud.
Sorry. God, that is loud.
Basically, what I in the early days of making it work, when I wanted the robot to drive, so Harold, you have basically your up vector, which is not pointed up. Well, it's pointed up from the center of the Earth, but it's not necessarily going through the center of the robot because the robot, as you say, may actually be visually leaning forward or backwards when it's balanced. Okay, so the way I made it drive was that I would cheat that vector forward and backward, and that would control. That's exactly like standing on a Segway. And the problem with that I found is that now if you hit a slope, you want to go up a ramp, you have to lean further forward to develop the torque to keep going.
To keep going.
And that the Segway, has a human on it who does that without thinking. But for the robot, it means when it hit the slope, it came to a stop. So the more current software keeps that. Let me see how to describe this. You keep that value that I said was set to 0. You keep it non-zero, so that the robot attempts to stay in the same location, and then you move the location. So you actually have this fiducial point that's directly under the robot when it's balanced. And when you want the robot to drive, you move that point out from under the robot.
I got it.
So you can think of it, I think of it kind of like a bungee cord out in front of the robot. Now, when you hit that slope, that bungee cord is going to stretch and get tighter, and it'll cause the robot to ramp up its torque, and you'll get the right angle to climb the slope. It also means that if you unbalance the robot, like hang a heavy weight on one side, it'll find a new balance point. It will automatically find the balance point. So whether that up vector is not in your control anymore.
Yeah, that's one of the things I was playing with. I'm using there's something called QuickPid, which is doing very similar things that will automatically find the set point. Now I don't know exactly what it's doing to do that. And I did have some success with some of that, but then, like you're saying, no, I don't want that thing automatically finding the set point, because my thought is very much similar to what you were thinking, what you just told me. I want to initially start where it stands up and it's there for somebody pushes it, and somebody's being a jerk at my desk and walks by and pushes it, straightens itself up, right? Or not being a jerk, just playing with it. I want them to do that. But my thought was, in order to move things forward, my initial thought was do something very similar. You're changing the point at the bottom where it is. My thought was that I maybe change the set point by the slope of the angle to get it to move forward or backwards. And I can't automatically updating that thing and do that. So maybe I'm thinking about it backwards.
I noticed my camera seems to be.
And don't even get me to talking about how do I turn this thing and remain balanced. I haven't got my brain.
Well, it's trivial. The algorithm doesn't care whether it's turning. All you got to do is add a offset to one wheel and subtract it from the other wheel. It doesn't affect the balance algorithm at all. Okay. I was actually surprised when I learned that.
Yeah, see, that right there has been one of the things checking around on Brian. It goes like, man, now I've got to go do some things and stuff, and that's going. So okay. So
well, let me describe the following, and maybe it'll make it more clear. Let's imagine that you have the robot perfectly balanced, sitting still. And in this case, we're not going to move the fiducial point. We're actually just going to move where it thinks up is. So suppose my hand represents the robot, and this is the front of the robot, and I want it to go this way. So what I'm going to do is I'm going to tell it that its up angle is not here anymore, but it's here. Okay. Well, now that may seem backwards. I'm saying it's behind the up angle when I want it to go this way. Okay, what the robot will do at that point, when I say the angle is now here, the robot will say, okay, up is behind me. And so it will try to drive backwards. And when it does, the top of it will fall forward. And because the top fall forward, it will drive forward.
Yeah, I got you. Yeah, I think I'm tracking out what's flashing in my brain is like back in my statics and dynamics that I'm back in college. We had one of our problems, and because we get problems all the time about stuff, and it was very surprising, and the math kind of bears this out. You take a spool of thread, you got an internal diameter and an external diameter, and if you put it on a piece of table, and you have a technically friction full surface where you got no slippage, and you pull on the thread, which way does the spool roll? So
it rolls away from you, right?
Roll away from you.
No, my friends. Spool, internal, floor. Everybody see that?
No.
Get closer. Oh, hold on. Let me do this.
Nope.
Oh.
Oh, hold on. I do this all the time. What am I thinking?
See, white cow in a snowstorm.
Okay. Everybody sees it? Maybe.
No. Well, okay. I see it there. I see a wheel.
That's the internal circle. This is the external one. Right? This is the floor. and there's thread, of course, warped around in the middle of all this, and this thread comes off. You know,
Wait. The thread is on the internal circle.
the thread's on the internal circle,
I got you.
and if you pull on this thread this way, which way? Because you got a circle right here, you got to center this thing. Which way is that spool roll?
I'd assume.
Well,
This is exactly
To
what
your
David
left.
just described, by the way.
okay, and so it's a friction-free surface.
No, it's ideal friction, meaning there's no slippage.
No slippage.
It rolls to the right.
Yes, it does. So here's what happens. All of this stuff can move. At this point where it meets the ground, that's still. That's stopped. The ground doesn't move. The thing moves, and at the point where the wheel's touching the ground, it's stopped. So you have a vector that goes right down here. Picture that as a lever. This is its fulcrum. I'm pulling here. Where does that point go?
Yeah.
Okay.
To your right.
Okay. Yeah.
Yeah, and that's exactly what you just described to me, but in slightly different terms. At least that's what my brain is telling me.
Well, you know, if you watch cartoon characters, watch Bugs Bunny run. The intuition of the cartoonist is exactly right. That you basically have to back up before you begin, and you'll see his legs do that. He starts to spin around, and his legs move backwards, and the top of his head leans forward, and then he takes off in that direction. It's exactly the way a robot works.
Yeah.
So, thumbs up to the intuition of the Bugs Bunny.
Exactly. We got real science going on in a Bugs Bunny cartoon.
The animators, yes.
And his feet make that little noise, and then he
Oh,
moves.
that's real. That whole sound is real. I've heard it.
Bongos.
So yeah, there is a video on this I see down here. So anyway, there's that, the base code is there, and he talks about the 173 degrees, which with regard to our balls, I understand now that. So this is what they have. So I guess I'll run this and see. But yeah, it looks like he has it pretty well balanced off the bat.
Yeah.
And you're right, the reel's not moving much.
Is he poking it or just letting it?
He's just letting it be there. So if he gave that a good hard push, he pushed it. Oh, that's a little bit of a hard push.
That's more than a little hard in my mind.
Harold, when I get it working,
Can you even
and
balance
if
one
I
of
ever
them?
do, when I put the robot in that fiducial mode, I can punch it hard with my fist and it won't fall over. I mean,
that's where I'm thinking.
Most of the balancing robots I see, when they reach in, they just barely touch it. They just give it a little touch.
Yeah.
I can actually slug it with my fist in that rubber bumper.
I'm thinking as small as this thing is, I could probably put some serious, because the way the motors are, and that's what I'm hoping to be able to do too. So I can put do a thump at it, not just a touch, but a thump at it and have it fix itself, because these motors are they're small, but they got some serious. They got some serious ump to them for their size. And of course, I've got a 2S 50C capable battery of 800 milliamps firing into the motor, so they have all the juice that they could stand, as far as they're concerned.
Well, maybe that's not for next week. We can look more closely at this.
Speaking of that, I got to learn a lot about RC ratings and 2S this, and EC2s are the devil, but EC3s are awesome, and all these other kind of things I had no idea I needed to learn before I kind of tried to build this robot thing.
I just want to build a robot. I don't want to have to learn anything.
Yeah, I had to learn all this stuff. This is crazy.
Beavis and Butthead. If I wanted to read, I'd go to school. Gentlemen, I've got to sign off here.
Okay.
It's great to see everybody again.
Great to see you too.
Hey, Paul.
Hopefully I'll get to do it more.
Yeah.
We'll see you, Dave.
See you, Dave.
Bye, Dave. Thanks for all the info.
Who I was trying to read. Oh yeah, Paul. It looks like the ones that I bought the most often have been discontinued. This was an ESP based, the 915 megahertz one that you'd use in US. It also had a little OLED display on it. Looking on Amazon, if you just look up ESP32 LoRa's, there seems to be several that are, look pretty good from. I think I've actually bought some stuff from DIY malls before. Those two may look similar. It looks like the price has gone up a little bit.
Yeah.
$52.
And you're pointing this out relative to the sidewalk discussion, right, Ray?
Yeah, those were the ESP32 boards that had the LoRa 915 megahertz transceivers on them.
So there's a thing to it doesn't appear to be particularly easy to start using the sidewalk is the only issue that I see, because looks to me like there's layer upon layer of encryption and keys that you have to get sorted out, and you have to hook it up to AWS IoT Core, and then you have to get your application server going that has to be able to register the device and generate keys, and there's seems to me so apparently some of the vendors like Nordic Labs and I think there are 3 others that are doing software development kits, SDKs for this stuff. You'd want to use their SDK, because there'll be a bunch of encryption libraries that you have to link against to get the whole protocol to work right. So I was not proposing that you can just take your ESP32 with LoRa and just fire it up and it could talk through the sidewalk protocol. There's a heck of a lot more networky goop in there than I think I understand.
Yeah, I was just using them point to point, so
yeah, right,
involved.
Right, and that's what we were using as well. And there's a couple of different, interestingly, over in Europe, I believe, there's an IoT protocol called narrowband IoT, NB-IoT, I think, which is based on LoRa using cellular frequencies, and they kind of tag on the edge of the cell phone network. No, it's not LoRa. I'm sorry, I misspoke there. But it's narrowband IoT. But it does use the cell network, but not in a full bandwidth configuration. But they don't support that in the US. So I'm sorry, I got off track there. I was thinking it was LoRa, but it's not. It's cellular. Well, it's taken me a whole meeting to make terminate an Ethernet cable on 2 ends in a way that works. I put about 2 connectors on each end. What a pain.
Yeah.
What a pain.
Okay. Well, guys, I have 9:58. I think it's time to call it. It's been a good meeting, and see you guys next week.
All right.
Yep.
Okay.
See you guys.
Bye-bye.
Bye.
Bye-bye.